So, good morning, my dear students. So, let us start our session. One general point: we can either be peaceful or we can be miserable. We cannot be both at the same time. So, let us move towards peace always. Peaceful mind, a focused mind, a purposeful mind. Alright? Now, when we are talking about rotation, look here. If I say that there is some mass there is a force which is acted upon here and it is trying to rotate about a particular point, I will get a torque. Torque is finding moment only, force multiplied by distance. So often in calculations, we have to choose the point about which we are finding torque. The point can be this, the point can be this, the point can be this. Depending upon the question, we have to choose the point about which a tendency to rotation can happen. Okay, and we should make our calculation accordingly. This point need not be always the center point only. Okay, so suppose there is a metallic rod is there. If there is a force which is acting here, if I am asked to calculate the torque about this point, means I need to put this distance. About this point means I need to put this distance. And I should be very careful about the sense, whether it is clockwise or anti-clockwise. We have discussed this point that if it is a clockwise, if it is an anti-clockwise, we are taking this as positive. And if it is clockwise, we are calling it as negative. Only for differentiating them. Because both we cannot positive. One is like this, another is like this. Both cannot be same. So direction also matters. Okay. So based upon this, so let us say this sign, this 3753, once I want to tell you, often in questions you are given a 37 degree angle. So 37 means this is 3, this is 5 and this is 4. Make a note of it, it's very important. Sometimes you are given 53 angle. This is standard they give. So this is 53, this is 4, this is 5 and this is 3. So what is 37 means? Sine 37 is 3 by 5. Sine 37 is 3 by 5. If suddenly sine 37 you see, don't think that what is this 37, how to calculate. This is a standard value. And here sine 37 is, sine 53 is 4 by 5. So from 0 to 90 degrees, sine value should increase. So sine 37 is 3 by 5, sine 53 is 4 by 5. 4 by 5 is bigger than 3 by 5. So just you should know these values. So we will see one numerical based on the concept of rotation. Look here. Quite often, this type of questions are asked. This is a ladder. Its mass is given as 10 kg. Okay. Its mass is given as 10 kg. It is kept in a slanting position with respect to the wall. And this wall is smooth wall. Wall is what? Smooth wall. अब वो smooth है rough है इसमें कोई फर्क नहीं है. Whenever you see smooth, that means mu is equal to 0. We have to get the information from the question. Okay? And the floor is rough. The floor will have some new value. What is rough means? This ladder is resting on the ground means there must be some friction between the ladder and the ground. There must be some friction. So here there is no friction. And in the question they are asking you to find out the value of normal reaction. Alright, you have to attempt this question now. Now, while attempting this question, first we have to draw the forces. See, this ladder is touching the wall here, so it will have a normal reaction. A block sitting on a table will have a normal reaction like this. If the block was like this, the normal reaction will be like this. So this is the normal reaction N1. Okay? N1 and 2 we are writing because there are two. Similarly, here also there will be a normal reaction. What is this normal reaction? This is between the ground and the ladder. This is between the wall and the ladder. N1 is wall and the ladder. Wall and ladder. N2 is ground and ladder. Okay, you can see their directions are different. This is perpendicular, this is horizontal. Now, this ladder will try to slip in this direction. The frictional force will act towards left. The frictional force will act towards left. And we have to find whatever unknowns that are given in the question, we have to find out that. Okay. So how to proceed with this question? Look here. Now the ladder, is it standing, means it is now equilibrium. So the ladder has its own mass, so its own weight will act at the center of gravity. So this is the center of gravity, and this ladder length also is given, I think. Now ladder length is not given, only this angle 53 is given. So 53, if it is given, we know that this is how much? 4, 5, 3. Or you can say 4L, 3L, 5L. It doesn't matter. So we'll say that this is 4, this is 5, and this is 3. So someone may ask, how do you know exactly this 4 meter? So it is some 4x, 3x, 5x. For simplicity purpose, take 4, 3, 5. Now this ladder will be acting in the self-weight will be acting in the center. So because this is an equilibrium, can we write sigma fx is equal to 0 and sigma fy is equal to 0? So I will say this is my x and this is my y. If I put sigma fx is equal to 0, what will I get? This f must be equal to n1. F must be equal to n1. Directly. F is positive, n1 is negative. F minus n1 is equal to 0, f is equal to n1. For the vertical case, n2 is balanced by this is sigma fx is equal to 0. I have some dust allergy, it seems. Sigma fx is equal to 0, f is equal to n1. Sigma fy is equal to 0, n2 is equal to W. Can we frame another equation? Is it possible? Because this is in equilibrium, these two conditions are which equilibrium? They are conditions for translational equilibrium. They are conditions for translational equilibrium. Can I apply rotational equilibrium also here? I can apply. When you say a system is in equilibrium, you say that it is in translational equilibrium, you say that it is in rotational equilibrium also. If you have cleared your JEE exam, that means you have cleared maths, you have cleared physics, you have cleared chemistry. It does not mean that you have only cleared JEE, only maths. So similarly, a system has many parameters. Translational equilibrium is one of them. If I apply rotational equilibrium, what did I tell you? Take about some point and calculate the moments about that point. They must be equal to 0. So if I take this point B, sigma MB must be equal to 0. Then only you can say that this is in rotational equilibrium. Okay? It is not rod. Rotational equilibrium. So sigma MB is equal to 0 means you need to identify all the forces. N2 force passing through B, N2 into 0. F passing through the point, F into 0. W, what is W? Mg, weight. So I will write W into this distance. W into lever arm. You are taking about this point. This is 3, so this will be 3 by 2. So W into 3 by 2 is the moment. But what is the sense as clocks? Clockwise is negative. Take this force. Will it create a moment? Yes, because there is some lever arm. So, how is the sense? It is trying to like this, anti-clockwise. So, plus N1 into lever arm. This is my lever arm. This is my lever arm. So, N1 into what is the lever arm? 4. Any other force? Right now, there is no other force. Had this been a rough wall, your friction would have been in the upward direction, then friction also will have a contribution. But here in the question, they have told you smooth wall. They have made your life easier. Okay? Solve it. So this is 3W by 2, N1, 4N1 is equal to 3W by 2. The weight is given as 10 kg. So weight will be 100 newtons. So N1 will be equal to 3 by 2 into 100 by 4. How much is it? This is 50. So 150 by 4, 75 by 2, 37.5. 37.5 newtons. Once you have got the value of N1, can I find the value of friction? I can find the value of friction. It is also N1 only. So once I think you have solved all the unknowns. Here, what is the problem? Here, weight you know, you can get the value of N2, but you don't know the value of N1. Here, both are unknowns. So you need another equation. That equation is created by this rotational equilibrium concept. If some student comes and says, sir, you have taken by this point, I will calculate about this point. Will I get a dream or what? That I should take about this. You can take this point. You can take this point. You can take some other point in Jumlitalaya. Even then, your answer won't change. Okay? So, make a note of this point that sometimes you have to frame some additional equations to calculate the unknowns in the system. The unknown in the system here is what? The N1. The N1 is the unknown of the system. If technically you want to write F, how can you write F? F is equal to mu times the normal reaction. It is mu N2. Actually, you can write F is equal to mu N2. So, in this particular question, if N2 is known, you can find F also. So, you can get N1 also. Actually, this is not required. Okay? If any bright student comes and says, why this is not required, I'll calculate like this, he is right. But just to teach you a concept, a point, we have framed another equation. So sometimes, let us say, if this wall was not smooth but rough, then here will be some other friction value, here some other friction value. Your number of unknowns are increasing. In that situation, what you can do? You can take one more point and again calculate the moments. So you will be getting number of equations. With those equations, you can solve for the unknowns. Okay? So please make a note of these points and write down. Students, let us move on to one very important concept in rotational dynamics, that is toppling. Toppling. In Hindi, what do you call it? Palti marna. Palti marna. So, when this type of situation comes, we have to understand that. We come across terms called sliding. Sliding का क्या मतलब है? If there is a road and a car is going and you applied a brake, what will happen? With a screeching sound, it will go forward. Okay? The car tire will remain as it is and it will go like this and somewhere it will stop. So this is called sliding. There is no rotation involved in that. There is no rotation. The car tire will skid. It will just, go forward and stop. Now what is toppling? अगर कार ऐसे पलटी मार दिया तो, call it somersaults, isn't it? So toppling, when that type of situation comes, we have discussed this point that suppose there is a metallic rod and its length is 1 meter. Okay, here I put 10 Newton force and 10 Newton force. Is the system in rotational equilibrium? It is in rotational equilibrium because if I calculate this torque, this is 10 into 0.5. This is 10 into 0.5 about this point. This is clockwise, so this is minus, this is plus. Add these two, you are getting 0. Suppose instead of 10, it was 20. What will happen? This will increase. In that situation, sigma t is not equal to 0. Sigma t is not equal to 0. Then what will happen? This will be, it will start rotating. The situation will become something like this. It will start rotating. So for toppling, we have to calculate the torque about the point where you can expect it to topple. So we will see one example. Let us say there is a block. Okay, this block has got some weight W. It will have some normal reaction. Normal reaction will pass into the center of mass. You apply a force here like this, and because of and let us say this is a rough surface, so there will be a frictional force developed in the opposite direction. Let us say this height is D and this is my A. Okay, so when you keep on increasing this force, I will call this point as O. So if you observe here, this friction, this force, external force, it is trying to, it is developing a torque about this point, isn't it? Force multiplied by distance is creating a torque about this point. So what is the sense? Sense is anti-clockwise direction. So someone must be balancing it. This force, friction, we cannot balance it because friction is passing through that point. Then who is balancing it? This normal reaction, there is a weight. Okay, this normal reaction, how the normal reaction has come? Because it is initially in equilibrium, so your normal reaction will be equal to the weight of this. So this weight, if you observe, it is kind of giving you anti-clockwise torque in this direction. Till the time these two are balanced like this, it won't topple about this point. The moment there is some unbalanced torque is created, this block will be toppled about this point. So actually what happens is, this normal reaction which is supposed to pass through the center, what it will happen is, it will shift. It will shift. Okay, so you see, this is creating a clockwise torque, and sorry, so let me cough. So this force is creating a clockwise torque about this point. So because the block cannot move, this who is balancing it? Basically the weight is balancing it. If the weight was less, it will be toppled. So what will happen is, this normal reaction, you can say it is some now distance, you can say some x. Okay, now this is going to balance. So that means what is this normal reaction? Normal reaction is mg only. So it will be acting at, instead of this point, it will be acting at this point to create a counter effect. So you can write here FB. FB is, I'm in bracket writing clockwise. This is balanced by mg. It is the force multiplied by some x. This is anti-clockwise. This is anti-clockwise. So the toppling effect by this force is negated by this anti-clockwise torque. Suppose if FP is more than mgx, what will happen? This force will be adjusted. If you slightly increase this force, what will happen? This line will be shifted towards left to counteract. If you further increase, it will be further shifted. If you further increase, further shifted. But beyond a point, what will happen? This line will go somewhere outside the block. That is not possible. So when you keep on increasing this force about this point, what will happen? The normal force will adjust itself. The normal force will adjust itself. Okay. Now here, please don't, normal reaction is the upward direction, sir. This is also clockwise, this is also clockwise. Don't get into that. What I am trying to say is, when this is trying to topple, the block is there only, but the counteracting effect of the torque, that line will shift. You can say the normal line is shifting. Okay. So if you keep on increasing force, so this line will keep shifting to the left. Okay. After some point, it cannot go outside the block. Then what will happen? This block will be toppled about this point. Your diagram will then look something like this. Yeah, as it will lose contact. This is the loss of contact with ground. This is loss in contact with the ground. Okay? What happened? ये block ऐसे उठ गया. तो कहाँ उठ गया? You kept on increasing F at some particular F. What happens when sigma torque is no longer equal to 0? This block will be toppled about this point. So what is the value of that means? Fb should be greater than mg by x. So F should be greater than mg by b. What is the maximum value of x? It can be a only, no? X can be maximum a only. So when F is more than mga by b, what will happen? The block will be toppled about this point. So this is quite frequently tested in competitive exams. So first, the concept of toppling. Toppling मतलब जैसे अब ये this spectacle box is there. So ऐसे हो जाना. If it is going like this, it is what is sliding. Okay. लेकिन ऐसे हो जाना, that is toppling. So this is what we have discussed here. So make a note of this one. So many times questions are asked on this concept.